Question number 2. Divide 20 into two parts that the sum of their squares will be minimum. Divide 20 means 1 and 19 mean we make two parts of 20, 1 and 19. Similarly, 2 or 18, 3 and 17, and similarly onward we can make partition of 20 in two parts. Now these all numbers 1 and 19, 2 and 18, 3 and 17 and onward, 4 or 16 and 5 and 15 similarly onwards, these all numbers returns the sum is 20. But we have to find these two numbers whose sum of the squares will be minimum. Means 1 square plus 19 square, 2 square and 18 square. So we have to make this result or this result and similarly onward, which make a minimum value. So again we take help of the maximum minima theory. So let me start our solution. First part is x and let the second part is 20 minus x. And according to the given condition or the required condition, sum of squares will become we can represent by s, and sum of these squares will become x square plus 20 minus x whole square. So s will become x square plus, just open the square of 20 minus x, which is 400 plus x square minus 40x, and s is equal to 2x square minus 40x plus 400. Now this one is the function which represent sum of the squares, and we have to make this minimum, and we can show this minimum function by with the help of our second derivative test. So first we differentiate this function, differentiate with respect to x. ds by dx is equal to 4x minus 40, and the second derivative is 4. Now for stationary points, put first derivative is equal to 0, which is 4x minus 40, and from here we can get the value of x, which is 10. Now put this x is equal to 10 in second derivative, we get d2s by dx square is equal to 4, which is greater than 0. And as we already know that if second derivative return a positive value or greater than 0 value, then the function whose second derivative is this one is minimum at that particular point which is going to be discussed. So we can say sum of squares is minimum at x is equal to 10. Our required condition is fulfilled now at this value, and this is actually our first part of our supposition. So first part is equal to x, which is 10, and the second part was 20 minus x. So just put the value of x, that will give 10. 20 minus 10 is equal to 10. So our required two parts are 10 and 10, which divide 20 into two parts, means 10 and 10. But their sum of squares will return a minimum value instead of all other possibilities. Like we can check 10 square plus 10 square, 100 plus 100 return 200, 5 or 15, 5 square 25, 15 square 225. So 225 plus 25 will give us 250. So we can check that this returns a minimum value instead of this 250. Similarly, you can compare all other possibilities, then that can easily be verified that this one is the required values which returns a minimum as compared to all other possibilities. Question number 3. Find two positive integers whose sum is 12 and the product of one with the square of the other will be maximum. Almost the first condition is similar to first two questions. So let the first positive integer is x and the second positive integer will become 12 minus x, as the sum is both positive integer is 12. Now according to the condition, and in this case the condition is product of one with the square of other. Now according to the given condition, and the condition is we have to make product of one with the square of the other. So our function will become, which is actually the product of the two numbers, and the two numbers are x and 12 minus x square. So product of one with the square of other, by simplifying that will become x, just open the square of 12 minus x whole square, which is 144 plus x square minus 24x, and p is equal to 144x plus x cube minus 24x square. Now we can differentiate with respect to x. So dp by dx is equal to 144, this is x, this x is not here, 144 plus 3x square minus 48x, and the second derivative is the derivative of 144 due to the constant will become 0. We have second derivative 6x minus 48. Now for stationary points, put the first derivative is equal to 0, which is 144 plus 3x square minus 48x is equal to 0. Now from here we can calculate the value of x. This one is just a quadratic equation. We can simplify it by factorization. The factors are x minus 12 and x minus 4 is equal to 0. So either x minus 12 is equal to 0 or x minus 4 is equal to 0. And from here we can calculate the value of x, which is 12, or x is equal to 4. Now we check the value at second derivative one by one. So first put x is equal to 12 in second derivative, we get d2p by dx square, 6 into 12 minus 48, as the second derivative was 6x minus 48. So simplifying, that will return 24, which is a positive value greater than 0 value, but we have to find the maximum value. But as the second derivative returns a positive value, so this represents that the product is minimum at x is equal to 12. So that is not possible. This is not possible because the product will be maximum at this value. So we check the second value, which is x is equal to 4, and put in second derivative, we get d2p by dx square, which returns negative value, which is minus 24, and product is maximum at x is equal to 4. As the second derivative returns a negative value, so product must be maximum, and hence the first positive integer, which was x, and we decided x is equal to 4. So first positive integer is x is equal to 4, and the second positive integer 12 minus x. By putting the value of x, we get 12 minus 4 is equal to 8. So we have two positive integers 4 and 8 whose sum is 12, and the product should be maximum of one with the square of other.